Particle as well as what? Wave nature, isn't it? So we have seen the wave phenomenon of the radiation. You can say light. Okay, light has dual nature. We have said particle nature as well as what? Wave nature. Yes or no, everyone? So now, if we consider particle nature and wave nature, what are the phenomena which explained? Okay, which can be explained by means of wave nature of light ray? We have seen light exhibits both the natures, no, dual as well as particle nature. So, certain phenomena of light we could able to explain by about what? Now, what happens here now when radiation? Okay, like we have considered light. Okay, heat content of light we are calling as radiation over here. Now, when light falls on metal surfaces, okay, electrons are ejected. This phenomena by imbibing wave nature we could not explain. Okay, just why? Because of which we are assume that so light consists of what? So quantum of photons, quantum of energy called what? Photons. So these photons when they fall, so each photon energy how much we have seen equal to h mu. So then out of this h mu amount of energy, each electron will absorb certain amount of energy and remaining amount of energy will be utilized to increase the kinetic energy of the electrons. Okay, so here this phenomenon what happened? No, and one more point we have seen in case of observation of photoelectric effect, Leonard and uh, what Hertz observations we have seen. So the photoelectric process is instantaneous process, isn't it? So limitations and all those things, wave nature we have seen. So by means of wave nature, okay, if we imbibe wave nature for the light, what phenomena we could able to explain successfully? Already we have seen. What are they? Interference. Okay, so diffraction. So all these phenomena, interference, diffraction, polarization, these phenomena by imbibing what nature to light we could able to explain by wave nature. We have seen Huygens wave theory and all the interference, Young's double slit experiment, diffraction, how wave phenomena we have taken into account, and polarization and all. And one more characteristic property of polarization, it has proved the transverse nature of light. Okay, that one keep in mind. Now, so here, so we are imbibing light. Okay, we are attributing light a particle nature by considering that light made up of okay, so this quantum of energy called photons. So these photons when they incident on this particular what metal surface kind of these electrons are ejected. So this particular phenomenon of photoelectric effect was explained by assuming light as a what nature, as particle nature. Okay, so now here, so depending on the situation when light interacts with, okay, when light interacts with light, actually we actually consider as wave nature ray. Okay, when light interacts with matter we consider as particle nature. Matter means your electron is a fundamental particle, okay, of matter, isn't it? So when what is happening here, so this scientist named photoelectric effect was first, okay, so explained by whom? Linar and Hall experiments we have done. Have you seen? So and then photoelectric effect was in mathematically was explained by whom? By Einstein. So what is Einstein's photoelectric effect? Yes, everyone. So what are the first we should know about here? So when electrons are falling on the metal surfaces, they have to release the electron. Means the electron has to overcome this particular binding force of this metal surface, isn't it? So electrons are loosely bound here, valence electrons you can say. But so when this particular energy of the photon is coming and interacting with this one, okay, so it has to overcome this binding energy. That minimum amount of energy required to liberate the electron from photometal is called what? Is called work function. Yes or no? So what is work function? The minimum amount of energy required to liberate the electron from metal surface is called work function. Okay. So already we have seen this value. So the minimum the minimum amount of energy required to liberate the electrons from where ray? Refer my class notes, all of you refer also notes this student, Jew student in Japan Motam. So the minimum amount of energy required to liberate the electrons from where? From metal surface. Okay, is known as what? Is work function. So for a given metal, work function is constant. For different metals, what work function will be different. Okay, yes or no? So we are seeing here the how much amount of minimum amount of energy is required. That is called here work function. Now say the minimum amount of energy required. Energy is minimum. Frequency also minimum. So h mu naught is equal. We call it as work function. So you can also say this is hc by lambda naught. See, and frequency is minimum, lambda naught is what? Maximum. So the minimum frequency is required to liberate the electrons. That means photoelectric effect to takes place. Okay, so minimum frequency, maximum wavelength. So if the frequency of incident light is lesser than this particular one, okay, so no photoelectric effect. no photoelectric effect. That means we cannot observe electrons liberated from metal surface. No photoelectric effect. So this minimum frequency is called what? Threshold frequency. Okay. So unless the value of what? Frequency of incident radiation is a particular value for a given metallic surface. If you supply minimum amount of energy, electrons will not be liberated. There is a some what? Limitation for the frequency or energy, you can say. So H is anyhow constant. So for energy of each photon is equal to h mu over here. So unless a particular specific wavelength or specific frequency radiation incident on the metal surface, we cannot liberate the electrons. That minimum frequency is called threshold frequency. That minimum energy is called what? We can hear work function. So here when frequency is minimum, wavelength is what here? Maximum. So if I write here C by lambda, must be what? Less than C by lambda naught. So if 1 by lambda no, so here lambda will be greater than lambda naught. So unless the wavelength is what? Larger than the threshold frequency. Okay. So behind this, see, lambda is less than lambda naught, threshold wavelength this is. So lambda more than lambda means lambda naught is lesser than lambda. Okay, so the wavelength must be what? Smaller than this one. Frequency must be larger than this threshold frequency. So if frequency is minimum, so mu is less than mu naught means minimum frequency is mu naught, or any frequency more than this mu naught will be liberating the electrons. Okay, so but any wavelength maximum certain value will be there. So if any wavelength is more than this, no photoelectric effect. Wavelength will be lesser than the maximum value, and frequency is more than the minimum value. Okay, this keep in mind. అర్థమవుతుందా for photoelectric effect. Okay, right. Now, so after this we have seen that photoelectric process is a instantaneous process. Okay, so here minute here intensity term first we define, then we'll talk how intensity affects. What do you mean by intensity? Energy per unit time per unit area, we call as what? Intensity of radiation which is falling. Yes or no? So amount of energy, this is equal, you can say h mu amount of energy per unit time per unit area is falling. So if you are falling a more amount of energy, so more number of electrons, more number of electrons may absorb the energy. This sorry, photons are falling, electrons are emitted. So more number, intensity is more means energy per unit time per unit area is more. That means number of photons is more, so photon energy is more. So then each and every photon is being absorbed by electrons. So more photons will be absorbed by more number of electrons. More number of electrons will be liberated from the metal surface. Okay, so intensity of radiation affects the number of electrons ejected from the metal surface. Okay, you please keep this mind. Okay, we'll consider how many number of photons are emitted also, we'll talk here. Okay, the point regarding intensity, frequency, wavelength also over. Now fine. Now out of the total energy incident, so what Einstein's equation says, can anyone tell what is Einstein's equation? See, we are not teaching new ray, this is revision part, keep in mind. Einstein's equation ఏం చెప్తుంది చెప్పండి? What is the Einstein's equations of photoelectric effect here? The incident energy or incident photon energy h mu utilized in two ways. Okay, whatever the photons incidenting on the metal surface, electron absorbs out of this h mu energy. Some energy is required to overcome the binding force of the metal surface, which we call work function. Okay, work function phi naught or w naught, you can say. And remaining energy, once the electron liberates, no, remaining amount of energy absorbed by the electron will be utilized to increase its kinetic energy. So kinetic energy, so we can also call kinetic energy maximum. So the work function is the minimum amount of energy, so whatever the energy is there, remaining will be utilized to increase the kinetic energy here. అర్థమవుతుందా? సో హెచ్ మ్యూ ఈజ్ ఈక్వల్ టు ఫైవ్ నాట్ ప్లస్ కేఈ మ్యాక్స్. సో హియర్ హెచ్ మ్యూ ఈజ్ ఈక్వల్ టు, యూ కెన్ రైట్ హెచ్ మ్యూ నాట్ ప్లస్ కైనెటిక్ ఎనర్జీ maximum, or simply you can say kinetic energy also. Okay, so now, so when you are starting with particular frequency of radiation incidenting, so it has to overcome the work function and this one. So if you draw the graph for mu versus this one, so mu becomes mu naught plus ke by h. If I draw the graph for frequency versus kinetic energy, what kind of graph I will get, Ray? There will be some threshold frequency concept here. So unless the frequency of incident radiation is more than this frequency, no photoelectrons will be emitted. So y is equal to mx plus c form this is. Yes or no? Y is equal to what form? mx plus c form. కానీ ఇక్కడ మీనింగ్ ఏంది ఇక్కడ mx plus c అంటే, సో y యాక్సిస్ యూఆర్ టేకింగ్ ఫ్రీక్వెన్సీ, y ఇంటర్సెప్ట్ కావాలి కాబట్టి మనం ఫ్రీక్వెన్సీ మీద డ్రా చేస్తే ఇలా ఉండాలి గ్రాఫ్. It will not be a graph like this. Kinetic energy on x axis you are taking, no? So kinetic energy తీసుకుంటున్నాం కాబట్టి ఇట్లా ఉండాలి గ్రాఫ్. So this is certain value of intercept, y intercept. Y is equal to, this is mx plus C. Okay. So if I take the slope of this line, what does slope of this line gives, Ray? Slope is what? Y is equal to mx plus c. We are saying no. M value ఇక్కడ ఎంత ఉంది చెప్పండి ఒకసారి. కైనెటిక్ x axis is kinetic energy 1 by h ఇస్తుంది slope. What does here slope is giving? 1 by h. So if you draw the graph for here frequency versus kinetic energy, when you are increasing the frequency of radiation falling, the kinetic energy of electrons liberated also increasing linearly. But unless you incident is for minimum frequency, no electrons limit. That minimum frequency is called threshold frequency, or maximum wavelength is called threshold wavelength. So behind that maximum wavelength, no photoelectric effect, and the frequency is lesser than this also, no photoelectric effect. So here slope of this graph when you draw for frequency versus kinetic energy is 1 by h. H gives here what? Planck's constant. H gives what? Planck constant. And already we have seen what are the experimental study of photoelectric effect we have seen yesterday. So when you are observing with upright potential and all, okay, experimental setup also we have seen. Just a brief review we will do, and then I will draw the graph. Experimental setup for photoelectric effect. What you have seen? Can you tell me? So we have what? A photosensitive metal plate which we are using as a cathode here. Yes or no? So to accelerate the electron, this is cathode. To accelerate the electrons, we are using here anode. So there is some potential difference we are maintaining here. Yes or no? So now these we are maintaining some potential difference. And these two are actually in a so quad window this coach mirikada. So like this we are keeping in a glass tube arrangement. So from here small window light will be okay made to fall on this surface. Now when the light is falling on this surface, what happens? So it liberates the electrons. So these electrons liberated will be accelerated by this positive potential. Okay, positive anode you can say. So now okay, so what you have seen downward circuit. So where we can change the values. So potential difference I am applying like this. So I can change the current in this lower portion by what? Rheostat arrangement. Okay. Rheostat. Okay, we can change the value of here current in the circuit, and we can measure the potential difference across this one by connecting ammeter in parallel. Sorry, voltmeter in parallel for this combination. So ఇలా చేసుకోవచ్చు మనం voltmeter. So ఇక్కడ ఏదైతే ఉందో you can connect here voltmeter in parallel. Okay. Now two-way plug key we have. ఇక్కడ connection ఇచ్చుకోవచ్చు. You can made a connection here. See, when two wires intersect like this, right? When they are overcoming, no, what you can they intersect, no. When you loop like this, no, they are not intersecting anattu. No connections anattu. So you can apply here. See if I consist positive here. ఈ కనెక్షన్ పెట్టాను ఇక్కడ నేను ఇట్లా కనెక్షన్ ఇచ్చాను అనుకో. సో దిస్ ఈస్ పాజిటివ్ నో. సో నెక్స్ట్ voltmeter. Okay. So somehow you maintain here positive potential, you maintain negative potential. When you connect here positive potential, no, what are the electrons are immediately they get attracted, no, they'll be moving this side. And sometimes what we do, we consider this one related to negative potential. When you go on applying negative potential here, electrons have negative charge, no. So because of what happened, the repulsion force, and they will be stopping and no current in the circuit. So that's why this two-way, this arrangement is there. No, this is what sometimes to apply positive potential, sometimes to apply negative potential. Okay, ఈ పాయింట్ గుర్తుంచుకోండి ఇక్కడ. So now, so when what happens here when the when you're incidenting this light from this one, okay, photons when incident, electrons are ejected here. So what does this particular experimental setup is showing for us? Okay, effect of intensity. So what is the first case we have seen? Intensity. So when you are increasing intensity, what happens? What do by intensity? Just now I have seen energy falling per unit time per unit area. When you are go on increasing on this cathode photosensitive metal here, okay, electrons are ejected. So what happens when you increase the intensity? When you increase the intensity of light, when you increase more and more, what happens? So photons falls here from this metal surface. Large number of what electrons absorb the energy of photons, large number of electrons emitted, because of which photocurrent increases. So how do we measure photocurrent is measured by the ammeter. So you can use here ammeter in series here. ఇక్కడ ammeter use చేసుకోవచ్చు మీరు. Ammeter in series, this particular ammeter measures the photocurrent. So if you observe, as intensity increases, the photocurrent value also increases. How? Increases linearly. This is first experimental observation. So practically you can send the light over here. You can increase the intensity of light incident on this cathode plate. So more number of electrons absorb more number of photons, energy per unit time per unit area kabatti. So large number of electrons ejected. When the number of electrons crossing a given area increases, obviously current increases. So that current increase in the circuit can be measured by this ammeter. So more is the intensity, more is the photocurrent. Okay, everyone. So intensity of light, what happens? Direct proportional to number of photoelectrons emitted per second. Keep in mind. Okay. Next, effect of potential and photoelectric currents. What is the effect of potential then? How we can say effect of potential? Yes, Ray. Can anyone tell? What happens if we increase the potential here? Then we consider stopping potential concept. When we applying here positive potential, what happens? Large number of electrons are accelerated. I is equal Q by T. No, so current increases. So, but when you go on applying here negative potential, what, what happens? See, if you positive potential, they are accelerating, current increases. But when you give negative potential relatively over here, what happens? Whatever the photoelectrons are coming toward this particular anode, okay, so towards right side you can say, but when you apply negative potential relatively here, so because of this one, what happens? The energy of the photoelectrons, what happens? So being opposed by this particular negative potential. అర్థమవుతుందా? So these photoelectrons loses the energy slowly, and what happens when they sometimes completely may stop, they may not reach this particular anode. So when they are not reaching here, there is no photocurrent, there is no what? Photocurrent. So stopping potential is the minimum negative potential. See all of you, minimum negative potential applied at this, okay, anode with respect to your cathode, so that no photoelectrons will be reaching the collector plate here. We can also call as collector plate. This you can call emitter plate. Okay, photoelectrons are emitted, no? So what is happening here? Whatever the kinetic energy, the maximum kinetic energy which the photoelectrons are having, kinetic energy, so by this what? Negative potential, we are stopping them. So as you know, V is equal to W by Q. The work done is equal to Q into stopping potential, if I say V naught. So whatever the see on this metal surface, when light falls, electrons are ejected. So the maximum kinetic energy of electrons, so they should not reach here, means you have to apply negative potential here. So this potential which you are applying means you are doing work in stopping the electrons. So change in kinetic energy is there. So work done is equal to change in kinetic energy. How much amount of work is done? W Q V naught. What is change in kinetic energy here? So final kinetic energy is zero, initial kinetic maximum. So change in, so this is doing negative work here. Okay, change in kinetic energy is negative here. So how much amount of potential is required to stop them? That is V naught. So V is equal to W by Q. The work required is equal to Q into V naught. Negative potential ఇది. Negative potential కాబట్టి change in kinetic energy negative వస్తుంది. 0 minus some value is negative వస్తుంది. Therefore, so maximum kinetic energy, the maximum kinetic energy of photoelectrons is equal to your charge of electron over here. This is E into the stopping potential we call as V naught. So this is the maximum kinetic energy and stopping potential relation. Okay, so how much maximum kinetic energy yesterday we have seen? When an accelerating some potential difference, half mv square is equal E into V we have seen. Yes or no? What the maximum velocity will be? Maximum velocity will be 2 ev by m under root. Are you following all of you? This is the maximum velocity. ఈ పాయింట్స్ కూడా గుర్తుంచుకోవాలి ఇక్కడ మీరు పొటెన్షియల్ అప్లై చేసినప్పుడు నెగటివ్ పొటెన్షియల్ డిఫరెన్స్ అప్లై చేసినప్పుడు what is the maximum velocity of this electrons ejected from what metal plate, that is equal root of 2 ev by m. V will be given as potential. Okay, all of you. Now next, if we consider the graph of here current versus, okay, if we consider the graph of current versus what, yeah, stopping potential. So you can say collector plate potential versus current. If you draw the graph, this is potential graph, Nana. So if we increase this potential slowly, what is happening? Photoelectric current is increasing. Okay, and some value after some time, see whatever the electrons are ejected, all of they will be reaching this collector plate. So slowly increasing current again becomes what? Number of electrons, all electrons emitted at this plate, they are reaching the collector plate. So after some time, what happens here? Current becomes what? Saturated. This is called saturated current. Now when you increase the potential, this is the situation. This is the value of current. You can say I1 value. Now when I start applying negative potential for this particular collector plate, so these electrons which are emitted, they are experiencing what? Repulsion forces, and this negative potential is what? Working against this kinetic energy and stopping them, isn't it? So if I go on reduce the potential at a particular value of potential called stopping potential, what is happening? There is no electrons emitted from this, they are reaching this collector plate, there is no external current in the circuit. So as a result, the current becomes here zero. So this minimum negative potential required to stop the photoelectrons emitted is known as what? Stopping potential. So this is stopping potential. Now, for example, if I increase the, okay, what you can say now, intensity, if I increase, what happens here? So for example, what you can call is I value are taking, no? So stopping potential versus current if I take. Now if I increase the value of intensity, say, so intensity pencha anukundam. So when I increase the intensity, what happens? What is the meaning of intensity? Whatever the energy is falling on this particular cathode plate, per energy per unit time per unit area is I am increasing. What happens here? When more number of photons are falls over here, more number of photons falls here, and you are applying here positive potential, all these more number of ejected electrons, they will be reaching towards this particular what? Cathode. So current is increasing. Okay, but now when you apply negative potential, so what happen now? So when, see, more number of electrons, more is the current, so you can say current value will increase. Nana, current value is increased, more is the intensity. Okay, more is the current. So say current value in I1 small initial current anukunta, this is now I2. Say intensity I1 I2 anukuntunna, capital values, intensity capital I anukuntunna. So right. So but if you apply negative potential, no, so if you apply how much negative potential for this right side element electrode, so that no, whatever the electrons are emitted at the cathode, they will not reach this anode, you can say. So that is what negative potential is, a stopping potential. If you observe that, if you increase the intensity, of course current is increasing, more and more number of electrons reaching. But what negative potential required to stop all these electrons? Negative potential remain the same. So stopping potential is independent of what? Stopping potential is independent of its intensity, radiation intensity. Keep in mind. Now if you further increase intensity, current may increase but stopping potential remain the same, current may increase. Therefore, so what you can say, so here, the stopping potential is does not depending on intensity of radiation. But what is increasing? Current. Current is depending on the intensity. Okay, this point you should keep in mind. And this kinetic energy maximum EV naught. So far any doubt here, you can ask me. Yes, Babu, are you following?
Yes, sir.
So what is on maximum kinetic energy depends on what? Can you tell me now? Maximum kinetic energy depends on what? Right? Maximum kinetic energy depending on what? Frequency of radiation. Okay, keep in mind. Maximum kinetic energy of the photoelectrons emitted depends on frequency of radiation. If I increase the frequency of radiation falling on the metal surface, what happens here? So frequency increases, work function remains same. Definitely kinetic energy has to increase. So maximum energy depends on the frequency which you are incidenting. Okay, keep in mind. So now if I write, so collector potential versus intensity graph, okay, for different frequency, if I consider how the graph will be. Graphs are important. జాగ్రత్త గుర్తుంచుకోండి. So if I draw the graph for what, Nana? So collector potential. Positive unte current will increase, negative unte current will decrease. So collector potential, and if I use different frequency radiation, okay. So now what happens here now? First of all, when I increase the, and this is current, you can say I value current. If I am drawing the graph, so particular frequency on this metal surface, a particular radiation is falling of frequency, photoelectrons are liberated. Okay, and kinetic energy is getting there. If I go on changing the frequency, so for a given frequency, you have particular value of stopping potential. Do you agree, all of you? So what happens here? Now particular value, so current there, now when you increase positive potential, current is increasing, becomes saturated current. Avuna kada? Now, if I change this, say this is for frequency mu1, right? If I change frequency mu2 such that mu2 is more than mu1, what happens? If I increase the frequency, already we have seen h mu is equal to h mu naught plus kinetic energy. This is constant, man. Work function is constant. When frequency is increased, kinetic energy is increasing. Only kinetic energy of photoelectrons is increasing. Work function remains the same. So what happens when kinetic, see, fast moving kinetic energy is what? Electrons are coming here, kinetic energy increasing. To stop them, definitely I have to increase the potential or not. So if you remember, I have given Bahubali example here. So when that fellow is coming with that particular bullock, ఉంది కదా, in case of Bahubali, you see, no, that particular bull, ఎద్దు ఉంది కదా, అవునా కదా, when it's coming with high speed, definitely this particular villain has to apply large amount of force to stop it. So when kinetic energy is maximum, we have to increase the stopping potential. Therefore, if frequency is high, if I increase mu2 more than mu1, so stopping potential is more. But it observed that the current remains the same, saturation current remains the same. So negative potential is more. If it is mu2, so if mu2 is more than mu1, kinetic energy of electrons also increasing. To stop fast moving electrons, okay, definitely you have to oppose, okay, with strong potential. So stopping potential also increasing. So stopping potential depends on what, Ray? If frequency is increasing, stopping potential also increasing. This statement clear, everyone? Yes, Babu. If you have another frequency of radiation mu3 such that mu3 is more than mu2, then again stopping potential increase, but saturation current value remains the same. Okay, saturation current. Why? Because given intensity, for a given intensity, if I am actually incidenting radiation, see, on the metal surface ఫ్రీక్వెన్సీ ఒకటే ఫ్రీక్వెన్సీ వాడుతున్నాం కానీ ఇంటెన్సిటీ ఫిక్స్ చేసాను అనుకుందాం. ఇంటెన్సిటీ కాన్స్టెంట్ చేశాను అంటే ఎనర్జీ పర్ యూనిట్ టైం పర్ యూనిట్ ఏరియా ఈజ్ కాన్స్టెంట్. బట్ ఇఫ్ ఐ గో ఆన్ ఇంక్రీజింగ్ సేమ్ ఇంటెన్సిటీ డిఫరెంట్ ఫ్రీక్వెన్సీ mu1 mu2 mu3 ఇట్లా చేసుకుంటే ఎలా అనుకో ఏమవుతుంది, కైనెటిక్ ఎనర్జీ పెరుగుతుంది కాబట్టి వాటిని ఆపాలంటే ఆ నెగటివ్ పొటెన్షియల్ కావాలి. కాబట్టి నెగటివ్ పొటెన్షియల్ వాల్యూస్ హియర్ ఇంక్రీజింగ్, negative potential. But so for a given frequency, okay, for a given intensity, number of photoelectrons what emitted is constant, so current remains the same, saturation current remains the same. Okay, these three graphs are important, right? Whatever the so far I have drawn. Arthamatunda? Right. Now for different metals, how do you compare? For different metals, how do you compare, right? So for example, I have what you can say for metal A, metal B. Say for metal A, if I draw the graph for frequency versus stopping potential. Okay, so equation we know h mu is equal to h mu naught plus kinetic energy maximum, and here this h mu is equal, of course, work function. Kinetic maximum is depending on stopping potential, h ev naught. So if I draw the graph, this is anyhow constant. So if I can already first case observation mu naught plus entrana e by e v naught by h. This is what equation here for frequency. So unless a particular minimum frequency radiation is incident, no photoelectric effect. That is called threshold frequency. And so this is ev naught by h. So what I am taking on x-axis frequency, y-axis what, this one. So మీరు ఏం చేస్తారంటే y వాల్యూ కాగా స్టాపింగ్ పొటెన్షియల్ డ్రా చేస్తున్నాం మనం. స్టాపింగ్ పొటెన్షియల్ కాబట్టి we can write this one like this equation nunchi ev naught is equal to h mu minus h mu naught. So I want v naught value. V naught is equal to h mu by e minus h by e into mu naught. Now this is in the form of y is equal to mx plus c graph. Y is equal to mx. X means frequency here. So h by e is m. X means frequency plus c plus but negative slope here. Minus h by into negative intercept, not slope, negative intercept. Ante if you extend this graph like this, okay, this is negative intercept, negative y intercept. అర్థమవుతుందా మీ అందరికీ ఏం మాట్లాడుతున్నాను? సో వాట్ దిస్ నెగటివ్ ఇంటర్సెప్ట్ ఈస్ గివింగ్ రే h by e into mu naught. This is what negative intercept c value. Y is equal to mx minus c graph ఉంది. So this is threshold frequency. Now if frequency is increased, what is happening? Stopping potential also linearly increasing. Okay, this is very important graph, గుర్తుంచుకోండి. Any doubt in this graph? Yes, Babu. For different metals, if I draw, this is for metal A. If I draw for another metal, definitely for another metal, whatever, some other what you can get. This threshold frequency will be there. By threshold frequency or work function depends on nature of the metal, man. This is B here. So for this inco value untadi ikkada me draw cheste itla. Okay, and as in frequency increases, stopping potential also increases. Why? Kinetic energy increases. To stop high kinetic energy particles, electrons, obviously we have to apply large negative potential. Obviously we have to apply what, man? Large negative potential. Is the statements clear, everyone? Yes, no. So one more graph we can say kinetic energy, maximum kinetic energy versus frequency also. Array, just now you have seen, man, kinetic energy maximum and frequency direct relation. Yes or no? Kinetic energy maximum increases with frequency, direct linear relation, but minimum threshold frequency is there, the graph will be straight line. Okay, clear all of you? So this is for what? Metal A, if I take emitter 1, emitter 2, like you can take metal A, metal B are 1, 2, threshold frequency may be different here. But as frequency increases here, kinetic energy of also photoelectrons also increases. So what kind of relation we have? Linear relationship. Okay. So these graphs, all of you please keep in mind. అర్థమవుతుందా ఏంటి
Yes.
right? Okay, this is what photoelectric effect. And what are the observations of photoelectric effect? Unless the incident frequency is what more than the particular minimum frequency, no photoelectric effect will take place. That we are calling as what? Threshold frequency. And what is happening here? Current to photo current depending on the intensity. And stopping potential does not depend on what? Intensity. Stopping potential depends on what? Stopping potential depends on frequency of incident radiation. Okay na? అర్థమైంది అందరికీ? So these 3 points you have to keep in mind, right? Now, so after this, okay, so ionison's photoelectric effect we have explained already. Quantum of energy మాట్లాడాము, kinetic energy maximum మాట్లాడాము, and graphs also we have drawn. And if you consider stopping potential versus frequency graph మనకి ఎలా వచ్చిందన్న? Stopping potential frequency ఇట్లా స్ట్రేట్ లైన్ వచ్చింది కదా. If it is slope, what does slope gives here? Stopping potential ఎక్కడ ఉంది ఈక్వేషన్? ఇదిగో. Yes or no? సో దీనికి స్లోప్ ఎంత వస్తుంది మనకి ఇప్పుడు? ఎంత వచ్చింది స్లోప్ చెప్పండి ఒకసారి? స్లోప్ y ఈజ్ ఈక్వల్ టు mx ప్లస్ సి, h బై e వచ్చింది. So if the graph is given for you, slope, stopping potential versus frequency, if it is slope h by e, so from this we are finding the value of Planck constant, and practically this value also got coincided, right? And which scientist tried to disprove this one? Millikan scientist. Millikan scientist tried to disprove photoelectric effect, and he in the process he found that the value of h which is coinciding with Planck constant value. And instead of disproving, Millikan he proved the validity of Einstein's photoelectric equation. ఓకే, అది గుర్తుంచుకోండి. సో దీని మీద గ్రాఫ్ మీద స్లోప్ మీద క్వశ్చన్ అడిగే అవకాశం ఉందిరా మీకు. అర్థమవుతుందా? నా సో రైట్ వన్ క్వశ్చన్ రైట్. ది వర్క్ ఫంక్షన్ ఆఫ్ cesium metal ray. Cesium metal is okay 2.14 electron volt. 2.14 electron volt. Find the threshold frequency for cesium. What is the answer? Yeah. What is threshold frequency? What is given? Actually, work function is given. What is the formula for work function? We have seen work function phi is equal to h into mu naught directly. Yes or no? Threshold frequency value ఏమో చెప్పండి ఇప్పుడు. This threshold frequency work function by what? H. So what is the work function value here? How much given? Therefore, threshold frequency is equal work function value is given 2.14 electron volt divided by Planck's constant value entara. Planck's constant value how much? H value how much? H value entara? 6.
6.62 into 10 power minus 30.
5 into 10 power minus 34 joule second. So this electron volt, this is joule. మళ్ళీ మీరు కన్వర్ట్ చేసుకోవాలి దీన్ని, ఓకేనా? సో if I write in joule 6.625 into 10 power minus 34 joule second. So if I write here, this is 2.14 into electron volt ని joule లో కన్వర్ట్ చేయండి. ఎంత వస్తుంది? 1.6 in 10 power minus 19 joule, isn't it? Electron volt. So next for 1 electron volt ఎంత? ఎస్ బై వి ఈజ్ ఈక్వల్ టు డబ్ల్యూ బై క్యూ కదరా బై. డబ్ల్యూ ఈజ్ ఈక్వల్ ఎంత? క్యూ ఇంటూ వి. సో క్యూ ఇంటూ వి. సో క్యూ ఈజ్ వాట్? చార్జ్ ఆఫ్ ఎలక్ట్రాన్. 1.6 in 10 power minus 19 కూలుంబ్. కూలుంబ్ వోల్ట్ ఈజ్ జౌల్ పర్ కూలుంబ్. యూ క్యాన్సిల్ ద జౌల్ రాదా ఆన్సర్? ఎంత వస్తుంది? ఈక్వల్ టు చార్జ్ ఆఫ్ ఎలక్ట్రాన్ ఓన్లీ. సో డివైడెడ్ బై హౌ మచ్ విల్ హ్యావ్? 6.625 into 10 power minus 34 joule second. This to get cancelled. Per second means hertz frequency. You simplify this one. That is the answer. Okay, and thus అంటే మీకు 5.16 into 10 power some 14 hertz వస్తుందన్న. Okay, this is what threshold frequency for the cesium metal. Now the work function of cesium metal is 2.14 electron volt. Okay, ఇంకో విషయం ఫామ్లో కూడా చెప్పాం మనం ఇక్కడ. So work function, say for example, work function, sometimes you'll ask threshold wavelength అడుగుతాడు మీకు maximum wavelength. So work function in electron volt, if it is given, or energy you can given, hc by lambda. Okay, hc by lambda. అర్థమవుతుందా? So lambda naught. So if I write down this value in case of what is the value means electron volts మీకు అరే ఏమన్నా ఆడు అనుకున్నాం కదా బై lambda is equal 12,400 by ఎనర్జీ ఇన్ ఎలక్ట్రాన్ వోల్ట్ అనుకున్నాం. ఇది ఎనర్జీ ఎలక్ట్రాన్ వోల్ట్ ఉంది. ఇప్పుడు ఫార్ములా ఏమొస్తుంది? 12,400 by lambda in angstrom వస్తుంది. అర్థమవుతుందా? హలో. So
Yes,
if
sir.
lambda asks, you can find out the lambda also from this one. So if work function is given electron volts, if he's asking lambda in angstroms, lambda in angstrom is equal 12,400 by energy in electron volt. You can conclude here what is threshold wavelength now? Threshold 12,400 by energy in electron volt is given as 2.14. అప్పుడు మీకు ఆన్సర్ ఆంగ్స్ట్రామ్లో వస్తుంది. గుర్తుంచుకోండి. ఇది సింప్లిఫై చేసుకొని ఆన్సర్ ఆంగ్స్ట్రామ్ అని చెప్పాలి. క్లియర్? రైట్. Now write one more question. Light of wavelength 5000 angstrom. Write the question there. So light of wavelength 5000 angstrom falls on a metal surface. Okay. So lambda value is given there. 5000 angstroms falls on a metal surface having work function. Work function value is given 1.9 electron volt. So asking find the, okay, the stopping potential is dash is asking. How to find stopping potential? Just now we have seen, no? What you have seen? Energy in electron volt or work function in electron volt is equal 12,400 by lambda in angstroms. Once you got the work function value, work function stopping relation ఏంట్రా? E into V naught కదా. సో కంపేర్ చేసుకో. ఫస్ట్ కనుక్కో ఇక్కడ వర్క్ ఫంక్షన్ ఎలక్ట్రాన్ వోల్ట్ కనుక్కో. 12,400 బై ల్యాండా ఎంత ఇచ్చాడు మీకు ఆంగ్స్ట్రామ్లో? 5,000 ఇచ్చారు. సో ఈ 2 zeros క్యాన్సిల్ అయిపోతే ఎంత మిగులుతున్నాను? This 12.4 by 5. So 5 2s are 10, 2 left, 5 4s are 20, again 2 left, 2.48 electron volt. Now as you know the formula, so energy, total energy required to liberate the electron is work function plus kinetic energy maximum. Isn't it? The work function maximum, sorry, kinetic energy maximum. So here we can find out now maximum kinetic energy ఏం రాసుకోవచ్చురా? maximum kinetic energy E into V naught రాసుకోవచ్చు. Okay, and this is work function. This is equal what? H mu. Yes or no? Incident energy కనుక్కోండి. Incident energy in electron volt. Okay, if I consider that will be incident energy. This is incident energy. If I consider incident energy, okay, what I will get? That will be 12,400 by lambda angstrom. ఎందుకంటే lambda angstrom లో ఇచ్చాడు కాబట్టి. So then what you will get here? This is incident energy. Incident and electron volt is 12,400 by 5,000. So 2.48 electron volt వచ్చింది. అంటే this energy, this is incident energy. How much we got now? 2.48 electron volt we got. And work function already given. How much given work function is? 1.9 electron volt. Now you can write E into V naught. So now if you simplify, E into V naught stopping is 0.58 వస్తుంది. 0.58. Okay, what? Electron volt. See this electron atom get cancel the voltage entera 0.58. Therefore stopping potential now? Stopping potential is 0.58 volts. I hope clear everyone. Lambda angstrom incident light wavelength ఇచ్చాడు. Light of wavelength incidenting. So incident energy కనుక్కున్నా 12,400 by lambda angstrom. So I got 2.48 and I know the Einstein's relation energy incident is equal to work function plus kinetic energy. Kinetic energy stopping potential relation is E into V naught. Yes or no? So energy is I found already stopping potential, sorry, work function given. So I found E into V naught. E into V naught value is 0.5 electron volt. E క్యాన్సిల్ అయిపోతే మనకి V naught ఎంత వస్తుంది? 0.58 volts వస్తుంది. 0.58 volts. Is it okay? Hello?
Yes, sir.
Yeah. Make it fast. Right, one more question of two different frequency light of two different frequencies. Work function also given. The ratio of maximum speed of emitted electrons. You have to find out the ratio of the ratio of the ratio of what is asking maximum speed. Come fast. What are the answers, Ray? Hmm.
1:2.
1:2 was an answer. Yeah. How you are done?
H nu equal to H nu naught plus Ke maximum.
H mu is equal to, yes, Rishi, tell.
H nu naught.
H mu
H
is
nu
equal
equal
to
to
H mu naught plus
H
Ke.
mu naught plus kinetic energy maximum.
Okay.
They have given in first case H nu equal to 1.
Energy incident is given, no?
Yes,
Yeah,
sir.
1 electron volt given. And work function is
Is
remains
equal
same.
to 0.5
Work function
plus.
also given, no?
Yes, sir. 0.5.
Next,
Half mv
0.5
square.
plus this kinetic energy maximum is equal to half mv1 square, you can say. Second case, what is given?
2.5
Energy is
given, sir.
2.5 electron volt. Okay. Metal
Same
whose
0.5.
same work function కాబట్టి రాసుకోవాలి ఇక్కడ 0.5 plus ke maximum dash అనుకోవచ్చు. ఓకేనా? This will be how much? 0.5 is equal to, you can write half m v1 square, and this is 2.5 minus 0.5, how much, right? 2. This also
2.
how much you can write? Half m v2 square. Asking ratio of the speeds. Masses of electrons same kada. So this is 1 by 4. The 0.5 is 1 by 2 by 2, 1 by 4. 1 by 2, 4 is equal v1 by v2 whole square. So what is the answer we'll get? That is 1:2. The ratio of maximum speeds these are, okay? Ratio of maximum speeds how much? 1:2. Monochromatic means single color, single value means single frequency, okay? So when a monochromatic, girls, no one is giving response, listening all of you. When monochromatic point source of light, monochromatic point source of light is at a distance, at a distance at a distance of 0.2 meter. 0.2 meter means 20 centimeter distance of 0.2 meter, from a photocell, a photosensitive metal. From a, he is saying photocell means which emits photoelectrons anattu. From a photoelectronic cell or photoelectric cell. From a photoelectric cell, photoelectric cell. We have nowadays solar cells, no? Only photocells are not. When light falls, electrons emitted. Emitted electrons are channelized, and current is actually taken in the circuit anattu. From photoelectric cell, the cutoff voltage and the saturation current given ray. From photoelectric cell, the uh, cutoff cutoff voltage means what? Stopping potential. Okay. Cutoff voltage and saturation current are respectively the values are zero point 0.6 volts is cutoff for stopping potential, 0.6 volts, and saturation current is given as 18 milliamperes. Current in terms of what? Milliamperes, 18 milliamperes. If the, now he's asking the distance of the source is changed now, right? if the if the same source is placed, same source, if the same source is placed, okay, at zero point 0.6 meter away. So points, the distance increased here. Before it was 0.2 meters, now points 3 times distance increased here. 0.6 meter away from the photocell. Okay, away from the cell, away from the photocell, away from the photocell. Okay, then options are given here. Okay, the first option is stopping potential will be 0.2 volts. Stopping potential will be 0.2 volts. Second option is stopping potential is 0.6 volts. Stopping potential will be 0.6 volts. And third option, saturation current will be, saturation current depends on what? More is the current, more is the intensity, depends on intensity. Saturation current will be what? 6 milliampere. 6 milliampere. Next, saturation current will be 3 milliampere is asking. Next, fourth point, maybe multi current, maybe single current. ఎట్లా కావచ్చు. All possibilities think చేయండి. Saturation current will be 3 milliamperes. Yeah, what are the options? Please tell me fast. త్వరగా. What is the answer, Ray? Yes, everyone. Yeah, stopping potential depends on what parameters? Can you tell me, everyone?
Intensity.
Stopping potential intensity depends. So stopping potential. అరే
Frequencies.
రానా బాహుబలి ఎద్దు ఇట్లా వస్తుంది, ఎనర్జీ ఎక్కువన్నట్లయితే ఎక్కువ ఆపాలి. ఎక్కువ ఆపేది ఇక్కడ ఎవరు? స్టాపింగ్ పొటెన్షియల్. దేని మీద ఆధారపడుతుంది? కైనెటిక్ ఎనర్జీ. కైనెటిక్ ఎనర్జీ డిపెండింగ్ ఆన్ వాట్? ఫ్రీక్వెన్సీ. More is the energy. Array. H mu is equal to H mu naught plus kinetic energy maximum, man. This is anyhow constant. Kinetic energy depending on what? Energy. So means what? Frequency. More is the frequency, more is the kinetic energy, more is the force. Okay, it has to apply to stop this high energy electrons. Okay, so stopping potential depends on what? Frequency. Yes or no? Not on the intensity. So what happening here? He's saying, so stopping potential will be same as it only depends on what? Frequency of light. Yes or no? And the saturation current will what? Directly depend on what? Intensity. But we know what is intensity first of all. Intensity is equal energy per unit time per unit area. Yes or no? So here, how much amount of energy is incidenting per unit time per unit area? Say for example, if I have this photocell over here, particular source of light over here, emitting the light here, at distance r, no. So if I take this r as radius, and if I consider, okay, this is a spherical area, you can say three-dimensional area, 4 pi r square. So I can write energy per unit time proportional if I ray 4 pi r square kabatti inversely proportional to what here? Square of the distance anattu. Intensity. Why? Because yes, is changing the distance of the source. Is changing what? Distance of the source is changing. So intensity will change. Frequency remain the same. Kabatti as frequency is not changing, stopping potential will remain the same. Stopping potential will remain the same. Now intensity is varying. So distance, how much before it was? It was before and the 0.2 meter. Now how much it is? 0.6 meter. So what happens now here? I dash by I is equal to R by R dash whole square. Before it was 0.2 meter. Now it is 0.6 meter. This is whole square. So 2 1 2 3 1 by 3 means 1 by 3. So what is happening? Intensity I dash becoming to I by 9. So intensity reduced to how much, Ray? Intensity is reduced to what? 1 by 9. And moreover, intensity means matlab kya hai? Energy per unit time per unit area is falling on the photocell. More energy is falling, more number of photoelectrons are emitted. Okay, so as we have seen current and intensity graph, how we have seen graph linearly. As intensity increases, current also increases linearly. So I can say new current I dash will also equal to how much now? I by 9, linearly varying. So before, how much value of photocurrent was? 18 milliampere. Now how much will be, Ray? 18 by 9 ఎంత వస్తున్నా 18 by 9 will be enter 2 milliamperes enter that is equal to 2 milliamps. So new saturation current is equal to 2 milliamperes and stopping potential remains the same. So stopping potential before it was how much? And which are stopping potential? Hello. 0.6
0.6
volts.
volts.
Yeah, 0.6 volts ante remain the same. So stopping potential remains the same. Saturation current you can change last option as 2 milliampere. So you can give multi current. What is the answer now here? 2 milliampere is the saturation current. So either three stay, only one option would have been correct. Okay, now. So what is the relation here? Intensity of radiation is inversely proportional with distance. As distance increases, what happens? Intensity at that reaching particular unit point, unit area, what happens? Decreases. Keep in mind. Right. Next. What number of photons? How do you find number of photons actually? Yes. How do you calculate number of photons emitted? Number of photons emitted will be ఎలా calculate చెప్పండి? Shall I go ahead? I'm going to the next slide. I haven't. Number of photons emitted. What is the formula? Total energy incident by energy of each photon. Energy of what? Each photon. This is number of photons emitted. Total amount of energy. How much amount of energy incident? Okay, divided by energy of each photon. What energy of each photon value రే h మీద డివైడ్ చేయాలి. టోటల్ ఎనర్జీని ఎనర్జీ ఆఫ్ ఫోటాన్ డివైడ్ చేస్తే మీకు నంబర్ ఆఫ్ ఫోటాన్స్ వస్తాయి. ఓకే ఎవ్రీవన్, రైట్ ద క్వశ్చన్ నో. ద క్వశ్చన్ వన్స్ ఆల్ ఆఫ్ యూ వాట్ ఈస్ ఆస్కింగ్. The minimum intensity of light to be detected by human eye is given. So the intensity Ryan first. What is asking? Intensity. So the minimum intensity which our eye మన కన్ను ఉంది కదా ఇట్లా. Okay, so this is I, no? So the detects, no? So minimum intensity detected by the eye is 10 power minus 10 watt per meter square. It can detect, right? The number of photons here, what is happening? Light entering means photons are entering our eye. అన్నావు కదా, ఈ పీపుల్ స్మాల్ పీపుల్ ఎంటర్ అవుతున్నాయి. Number of photons of wavelength given. Wavelength is equal to 5.6 into 10 power minus 7 meters. So how many number of photons will be entering our eye through pupil area of cross section 10 power minus 6 meters square for vision is asking. Our just now what I said, number of photons is equal to energy incident by energy of each photon. Yes or no? But intensity is given. What is intensity? Energy per unit time per unit area. This is E by AT. isn't it? So we want energy. Energy is intensity into area of cross section into time. So energy incidenting per second. Energy incidenting per second means I am making t is 1 second. So intensity into area. Intensity how much given? Intensity how much given? 10 power minus 10 watt per meter square into area. Area how much? 10 power minus 6 meters square. This is what? Energy. So watt. Watt means joule per second. This much amount of energy per second entering. అర్థమవుతుందా? Joule per second. ఆల్రెడీ మేక్ టైమ్ ఈజ్ హియర్ 1 second హియర్. హలో ఇంటూ 1 second చేయలేకుండా అర్థం కాకుండా ఇది క్యాన్సిల్ అయిపోతుంది మనకు. దిస్ మచ్ అమౌంట్ ఆఫ్ ఎనర్జీ ఇస్ ఎంటరింగ్. హౌ మచ్? 10 power minus 16 joules. Is it okay all of you? Hello Babu. So what you have to find out? Number of photons. So number of photons is energy incident per second. ఎంతనా? 10 power minus 16. 10 power minus 16 joule of energy per second entering. Okay, keep in mind per second it is. Okay, divided by. So what is the energy of photon? Energy of each photon in the value h mu. Yes or no? Energy of each photon h mu. So how to find mu? Mu for finding mu value, wavelength is given. For finding mu value, what is given? Man, wavelength is given. అవునా కదా? సో యూ కెన్ ఫైండ్ అవుట్ హియర్ సి ఎనర్జీ ఇన్ జౌల్స్ మీరు కనుక్కోవచ్చురా, లేదా ఎలక్ట్రాన్ వోల్ట్ కూడా కనుక్కోవచ్చు. మీరు డైరెక్ట్ రాసేయండి. ఇక్కడ ఏం చేస్తారు? 10 power minus joule 16 joule, h value is 6.625 into 10 power minus 34 joule second into c by lambda. C is 3 into 10 power 8. Mu value ni em రాస్తున్నా నేను? C by lambda రాస్తున్నా. C by lambda. Lambda goes up. How much lambda value given? 5.67 into 10 power minus 7 meters is given. When you simplify, okay, here per second you are getting here. So this is also joule per second, can joule per second, second cancel అయిపోతుంది. Mere number you will get. So if you simplify this one, the number of photons nearly will have some 300 photons entering per second. So what is the formula for number of photons? Total energy incidenting divided by energy of each photon. How do you find energy incident? From intensity. Intensity is energy per unit time per unit area. Energy per unit time per unit area. So from this energy will be intensity into area into time. Okay, per second I am calculating and simplifying. Is it clear all of you? Hello.
Yes, sir.
Yeah. This is what photoelectric effect, intensity, graphs and all things, right? Next next manaku. De Broglie wavelength. What is de Broglie wavelength? Everyone knows. And which experiment proved the wave nature of electron, right? Which experiment has proved the wave nature of electron? Davison and German experiment. Davison and what? German experiment proved what nature of light? What nature of electrons? Wave nature of electron. Wave nature of matter means matter also exhibits wave nature, that was given by de Broglie explanation. And experimentally matter means electron particle, you can say. So wave nature of electron was experimentally established by which experiment? Davison and Germer experiment. And unko the Compton effect that is not in our syllabus. Compton effect, photoelectric effect, all these are explained by what nature of light? Particle nature, photon nature of light here. Okay, wave nature of light, which phenomena were explained? Interference, diffraction, polarization, wave nature. Particle nature are here what? Photoelectric effect and Compton effect, they are explained by means of what nature of light? Particle nature of light. Particle means here we are considering light made up of photons, okay, which are considered as particles here. Right. Next, what is de Broglie wavelength? Everyone knows. Yes, as you are saying, what? Radiation has dual nature. Radiation means light has dual nature, particle as well as wave nature. So can here converse is true, he is asking. Can matter also behaves like a wave? Yes, the answer is right, and which was given by whom? De Broglie. Yes or no? So what that value has seen? De Broglie wavelength. De Broglie lambda is equal to h by mv. Yes, the beauty of this equation is left side is lambda related to wave, right side is momentum. Momentum is characteristic property of the particle. So like we have seen momentum p is equal to h by lambda అని చెప్పాం, గుర్తుందా? ఎట్లా వచ్చింది ఇది? Like see, E is equal to mc square మీరు తీసుకున్నట్లయితే ఎనర్జీ కన్వర్ట్స్ టు మ్యాటర్. ఓకే, మ్యాటర్ కన్వర్ట్స్ టు ఎనర్జీ. న్యూక్లియర్ ఫిజిక్స్ మనం మాట్లాడాం, isn't it? You can write simple for understanding versus mc into c రాయండి అన్న. ఎంసీ ఇంటూ సి మొమెంటం లాగా తీసుకోవచ్చు దీన్ని. అర్థమవుతుందా? ఓకే. సో దీని మొమెంటం తీసుకుంటే సో ఎనర్జీ ఈజ్ ఈక్వల్ మొమెంటం ఇంటూ సి తీసుకుంటే మొమెంటం విల్ బి హౌ మచ్ ఎనర్జీ బై సి. సో ఎనర్జీ బై mu ఈజ్ ఈక్వల్ టు సి బై ల్యాండా, సి ఈజ్ ఈక్వల్ టు మ్యూ ల్యాండా. Okay, E is equal h mu. So this is mu lambda. So what we will get here like h by lambda. So momentum of the particle is given by what formula? H by lambda. So here now if I consider de Broglie గురించి చెప్పొచ్చు మీకు ఇక్కడ చూడండి జాగ్రత్తగా. Lambda is h by mv, no? So p value how much? Simply h by lambda. This is what momentum of a particle. Okay, so here v is the converse true means particle or matter also behaving like a wave whose wavelength is given by lambda is equal h by its momentum. When a particular particle moves with particular velocity, it has some momentum. The ratio of what? Planck constant to its momentum gives its wavelength. That wavelength is called here de Broglie wavelength, which relates both material particle nature and wave nature. So lambda is equal h by mv. అర్థమవుతుందా? And lambda is called what wavelength here? Lambda is called de Broglie wavelength. What wavelength is called? De Broglie. Yesterday also I explained in the class. So for microscopic particles only we are considering macroscopic particles wavelength. When macroscopic particles ఏముంటుంది wavelength mass ఎక్కువ ఉంటుంది కాబట్టి wavelength బాగా తక్కువ ఉంటుంది. That wavelength we cannot measure. Okay, very small వస్తుంది. So during discussion I have done refer classroom notes once. Okay, so keep in mind. And sometimes if a particle is exert some potential difference like electron, proton, alpha particle, something they will say. Then what is the velocity we have seen formula? Root of momentum or momentum how much వచ్చింది root of 2m ev అని చెప్పాను నేను. గుర్తుందా మీకు అందరికీ? ఎట్లా వచ్చింది అది? Kinetic energy of fast moving particles is equal to E into V. Kinetic energy formula P square by 2m I can write E into V. So from this momentum is equal to root of 2m ev. Now de Broglie wavelength of such particles which are accelerated through some potential difference is given by h by p. P means root of 2m ev. ఈ ఫార్ములా గుర్తుంచుకోండి జాగ్రత్తగా. Following all of you, this formula, okay, this formula is very important, right? And Davison German experiment conclusion is that electrons also having what nature? Wave nature was confirmed. And what is the wavelength of the electrons over there? We have seen with respect to potential de Broglie wavelength associated with electrons. So when Davison and German experiment they are doing, so what they have done, they exert potential, no, with through what potential? Approximately 54 volts తీసుకున్నారు వాళ్ళు. 54 volts. Then we have seen the lambda is equal h by p అనుకున్నాం కాబట్టి మనం దాని నుంచి ఎంత వచ్చింది మనకు వాల్యూ? యా మొమెంటం రూట్ 2m ev చేసినాం. సో వెన్ యూ సింప్లిఫై lambda ఇక్కడ చార్ట్ చూడండి, lambda is equal h by root of 2m ev. When you simplify this expression, how much we got? De Broglie wavelength of electrons 1.227 by root v, where v is potential and wavelength in nanometer. ఈ పాయింట్ కూడా గుర్తుంచుకోండి. సో డైరెక్ట్ ఆల్సో యూ కెన్ రైట్ ఇఫ్ యాక్సిలరేటింగ్ పొటెన్షియల్ is given, de Broglie wavelength is given what? Root v. And when you substitute this value for electrons, how much we got for 54 volts? So de Broglie wavelength of electrons for this 54 volts, if you root 54, if you do simplify 1.67, right? ఎంత వచ్చింది మనకు? 1.67 angstroms. This is the de Broglie wavelength of the electrons. It's very small. ఓకేనా? అర్థమవుతుందా? Right everyone? And sometimes we use this kind of things in case of interference of, see, electrons can also exhibit interference. గుర్తుంచుకోండి. Why? Electron is also showing wave nature. అర్థమవుతుందా? Yeah, now write one question based on that. A beam of electrons, write the question. A beam of electrons also exhibiting wave nature kabatti they can also interfere. You can see interference pattern of electrons also. A beam of electrons with speed v naught, with speed vr, if the speed is doubled, what happens to the spacing between the fringes? Spacing between the fringes is called what? Fringe width. The region successive maximas or minimas. Spacing between the fringes on the screen. Yeah, see, this is called linked question, navigation question. So fringes on the screen. See how he is relating to what? Wave nature of electron he is linking with what? Young's double slit experiment. So here de Broglie wavelength is called for matter waves, matter particles. What wavelength you have to take? De Broglie wavelength you have to take. Fine, all of you. Can you think of this question, all of you? Young's double slit experiment. Screen, fluorescent screen is there. Fast moving electrons are allowed to pass through this one. So interference pattern is seen, he is saying. Okay, bright and dark maximas and minimas here formed over here. Interference pattern is seen here. Okay, he's asking before v is the speed here. So when electron having wave nature, that is taken as de Broglie wavelength of electrons is called h by mv. Okay, now when you consider h by mv, so for particular value of v, particular value of wavelength, when v is doubled, what happens? Wavelength, lambda and wave speed, how they are related? Sorry, lambda, wavelength of the matter wave. Okay, matter is electron here, wave, and its speed, how relation? Inverse relation. So lambda dash by lambda is v by v dash. This is v by, it is doubled, means 2v. So what happens wavelength now? Wavelength becomes half. And wavelength is reduced here. What happens? The spacing is asking. In case of interference pattern, what is the formula for fringe width beta? Lambda capital D by small d. So d constant, distance, screen distance is constant, slit width also constant. So beta proportional to lambda. When lambda becoming lambda by 2, so what happens? Beta dash becomes beta by 2. So fringe width also reduced to how much? Half. Means fringes becomes narrower. The monochromatic radiation of wavelength lambda 1. Shall I go next slide? Shall I go next slide? Yeah, a monochromatic wavelength, right, matter deterioration, right? A monochromatic radiation of wavelength lambda 1 is incident on a stationary atom. A monochromatic radiation of wavelength lambda 1 is incident on a stationary atom, as a result of which the wavelength of the photon, a monochromatic radiation, are you writing all of you? A monochromatic radiation of wavelength lambda 1 is incident on a stationary atom, as a result of which the wavelength of the photon after the collision becomes lambda 2 and the recoiled atom has de Broglie wavelength lambda 3. Incident on a stationary atom, as a result of which the wavelength of the photon after collision is lambda 2 and the recoiled atom has de Broglie wavelength lambda 3. Recoiled atom has de Broglie wavelength lambda 3. Then relate the wavelengths. Yeah. So what you have to do, can you tell me here, all of you? You know relation, keep in mind. Lambda is equal to h by p okati and lambda is equal to what? h by p means what? De Broglie wavelength kada? Anna kada? Rp is equal to h by lambda. Missed h by lambda. See here, when the incident wavelength is lambda 1 of photons colliding here with the atom, then what happens? Again another wavelength emitted here and is recoiling. So if I consider this phenomenon of lambda incident radiation and atom as together as my system, no external forces acting here, so what I can call is I can conserve the momentum. So momentum before recoiling is equal to momentum after recoil of the atom. So before, for the system, only radiation has momentum, and this particular particle is not having any velocity at rest. Its momentum is zero. So what is the momentum of radiation? Momentum of radiation is h by lambda. So h by its wavelength is lambda 1. So atom is at rest. Its momentum is zero, and after recoiling, it is de Broglie wavelength is given. So its velocity is some v. De Broglie wavelength is equal to h by p. So de Broglie wavelength momentum is how much? H by lambda. So it is what direction? Before and after you can conserve, no? Before is this one. So now after we are recoiling now. So how much now after radiation is going the same direction now here? Emotion degree h by lambda 2. So radiation is, and this one plus one more last question, manam. One more is what? Momentum conservation. By conservation momentum of the radiation before plus atom is equal to that it recoiled de Broglie wavelength he has given. Okay, the photon after the collision becomes lambda 2 and the recoiled atom has de Broglie wavelength lambda వాడే ఇచ్చేసారు recoiled wavelength ఇచ్చాడు కాబట్టి సో recoiled wavelength of this atom is h by lambda 3 రాసుకోవాలి. ఎందుకు lambda 3 wavelength momentum will be h by lambda 3, momentum will be h by lambda 3. So this radiation is momentum is h by lambda 2, recoiled wavelength all recoiled word which is simply plus తీసుకోండి h by lambda 3. So when you simplify what will have 1 by lambda 1 is equal to 1 by lambda 2 plus 1 by lambda 3. So if you LCM take lambda 2 lambda 3 divided by lambda 2 lambda 3 is equal to 1 by lambda 1. So what is the relation now? Lambda 1 will be lambda 2 lambda 3 divided by lambda 2 plus lambda. So this is what wavelength of the incident radiation. Okay everyone.
Sir,
No.
sir, the second lambda 3 will be negative, no? It's an opposite direction.
recoil అని చెప్పాడు. See the word he has used what? Recoiled. Normal వేరేదని మీరు మైనస్ తీసుకోవాలి అక్కడ. But already he used the word what? Recoiled. Okay, atom has de Broglie wavelength lambda 3 అని ఇచ్చాడు. ఓకే
Okay, yes, sir. Thank
ఫైన్.
you.
కాబట్టి రికార్డ్ కాబట్టి ఆల్రెడీ వాడే మెన్షన్ చేశాడు కాబట్టి మామూలుగా డీ బ్రోగ్లీ వేలంతో ఆటం కనుక్కోమంటే మైనస్ తీసుకొని చేయాలి మీరు అక్కడ. ఓకేనా? రైట్?
Yes, sir.
రైట్. Yeah, till here you once all of you see this one and next week continue. ఓకేనా? యా థ్యాంక్ యూ. ఐ విల్ సెండ్ మన అసైన్మెంట్ కూడా పంపిస్తాను, చూసుకొని ప్రాబ్లం లేదు, హోంవర్క్ ఇచ్చేస్తాను. Yeah, tomorrow we have nuclear binding energy, radiation Q value, radioactivity, nuclear energy, fission and fusion reactions. And next day after tomorrow, EM waves and communication, semiconductors. Okay. లాజిక్ చెప్పేశాను. కమ్యూనికేషన్ చూడాలి ఒకసారి, నేను చూస్తాను కొద్దిగా ఎనర్జీ దాని తర్వాత మధ్యాహ్నం చెప్తాను ఒకసారి ఉంటే. ఓకే, కమ్యూనికేషన్లో బేసిక్ ఇంపార్టెంట్ థింగ్స్ చిన్న చాప్టర్ అది అయిపోతుంది 11.5 hours. Shall I end the session? Yes everyone.